So here's the first item on the worksheet from our last class. We're going to take two 8-bit binary values, 0011, 0110, and use the AND function to combine it or operate on those values with a second set of inputs. We'll call this input B. It's 8 bits in series, right? But the way we have this organized, these are parallel operations. So I'm going to combine 0 and 1, 0 and 1, 1 and 1, 1 and 1, 0 and 1, 1 and 1, 1 and 1, and 0 and 1. Because we're using AND, both inputs for each series of calculations need to be a 1 in order for the output to be a 1. We don't have a 1 here, so our answer is 0, 0. We do have two 1s here. I'm sorry, here and here. So our third value is a 1. Our fourth value, when we AND 1 and 1 in the fourth column from the left, is a 1. This is a 0, this is a 1, this is a 1, this is a 0. So our final answer is 0, 0, 1, 1, 0, 1, 1, 0. Isn't that interesting? So if I have all 1s and I AND them, I guess the question I'm asking is, does my output change? Here's the input for A. Here's what happens after I AND it with all 1s, the input B. Here's the answer that comes out. How does input A and the output vary? What do you notice?
It's equal.
It's equal. It's the same. That's an important, see, we did that on purpose. That's really important. That's a really important understanding to have, especially when we start getting into networking. There are Boolean functions that are used with binary values and networking addresses, and it's very important that some of the results turn out to be the same and some turn out to be different. It's called a subnet mask. We'll talk about that a little bit later. But AND is used to calculate the network address identity and the client address identity in a parallel set of calculations for the network identity, for the network address and the subnet mask. Don't worry about all that jargon right now. Are there any questions? Are there any questions about item 1 and using AND to combine these 8 sets of binary pairs in parallel? Any questions?
No question.
Okay. So now we're going to turn this around and we're going to use OR. We're going to do the same thing. We're going to have the same, we're going to use the same value for input A. We're going to use the same value for input B. Except this time we're going to subject it to OR instead of AND. Once again, the pipe symbol is also another way to represent mathematically the logical function OR, the logical operator OR. If either A or B is a 1, then my output is a 1. So what do you notice about this outcome? What does your answer match in this case?
B input.
It matches.
Matches B.
It matches B input.
It matches
B input.
B. It matches B. If one of the inputs is all 1s, the output is going to match whichever input was all 1s, right? So that's an intriguing behavior. If you think about it, I'm going to preserve my input values if I use and. If the other value is all ones, I'm going to change my input values to the inputs that are all ones if I use or, right? Any questions on the second example we covered? Same problem, different operator. Totally different result, right? Okay, no questions. I take the same value as A in the previous two examples, and I apply not. Now in this case, we don't have two inputs, we only have one input at a time. So my 0 becomes a 1, my 0 becomes a 1. What's a not 1? A 0. A not 1 becomes a 0. I just flip it, each one down the line. End up with the reverse value, 1, 1, 0, 0, 1, 0, 0, 1. So what are we saying? We can take a single value, 8 bits in a byte, and if we AND it with all ones, it doesn't change. If we OR it with all ones, it changes to all ones. And if we feed it into a NOT, we get the reverse image or the reverse value, right? 1, 1, 0, 0, 1, 0, 0, 1. Any questions about the third problem?
No
No
question.
questions.
Here's the fourth one. This one's a combination. I'm going to take 0, 0, 1, 1, 0, 1, 1, 0, and I'm going to OR them, and then I'm going to NOT them. Well, that's the same as saying I'm going to do step 2 and step 3, right? So when I OR them with all ones, they become all ones. That's the first answer. So there's an order we have to follow here. And then the last thing I'm going to do is apply NOT to the first answer. So they become all zeros. If that's what you did when you completed your worksheet, you're good to go.